all of these examples are going to practice difference of squares. And A is the easiest one. If you have a difference of squares, the first ones have to give you A squared, the last ones have to give you B squared, and there's nothing in the middle. And if there's nothing in the middle, one has to be positive, one has to be negative. Because if you multiply this out, do you see that your outside and inside cancel out? So if you have something squared minus something squared, this will always be the case. So in B, do I have something squared minus something squared? Yes. I'm going to make a big set of brackets. What's the first thing that's squared? It's a 3x plus 4, and I'm going to keep it in a little set of brackets because it's more than one thing. What's the second thing squared? It's a 2y minus 1. I'm going to put that in brackets. 2y minus 1 and 2y minus 1. One has to be plus, one has to be minus. Something squared minus something squared is always the first ones. One's plus, one's minus. And then on this question, could we simplify? Yes. I'm going to have 3x. I'm going to have the plus 2y, but the 4 and the minus 1 could be combined to be plus 3. And the second one, I have a 3x, I have a minus 2y, and the 4 minus a negative 1 will be plus 5. There is my final answer. And I will tell you that if you multiplied this one out early and didn't see the difference of squared, you would have no hope of factoring. Wow. Little to no. You can do it. You know how to use AI. Fair enough.
That's too clever.
Okay.
Yeah, flex again.
I do. Here, let me just pause the video.
Yep. You should.
And then part C. Part C, 27, I'm going to rewrite it out here. 27, we have x plus 2x minus 3 all squared minus, and then we've got 75 y minus 4 squared. Okay? If they add extra stuff, that's hard for our brains, right? It gets busy. Things that are busy for our brains make it a little bit more challenging. Some of us are able to deal with busyness, and some of us don't like the busyness. Okay? So I'm going, for those that don't like the busyness, I'm going to say, there's a way you can make it easier. Let's just make it less busy. I'm going to let A equal the 2x minus 3 and B equal to y minus 4. If I do that substitution, do you see my question is now 27a squared minus 75b squared. Does that feel less busy?
No.
Yes. Now that I've done that, is this a difference of squares?
Yes.
Wait, I have no idea.
It's 20, what times 1 is 27? Is there a nice number?
3 and 9.
But it's the same number though. If it's a difference of squares, it's going to be like 5 times 5. Is that 27? Yeah, if you make a little mistake, right? These aren't perfect squares, which means there's probably a common thing you can pull out. What number can I pull out of 27 and 75?
3.
3. Leaving me with 9a squared minus 25b squared. You see that that is now perfect square, perfect square. 3a, 3a. 5b, 5b. 1 plus, 1 minus. So I just did it simply to begin with. And now what can I put in? Instead of the a, I can put back in the 2x minus 3 plus 5. And instead of the b, I can put back in the y minus 4. Same thing here, 3. Instead of the a, I can put back in the 2x minus 3 minus. And instead of the b, I can put back in the y minus 4. Can I simplify these? Do you see that you would get a 6x, a plus 5y, and the numbers minus 9, minus 20, minus 29. Second one, I'm going to get a 6x, the y is going to be minus 5y, and my numbers minus 9, plus 20, plus 11. Okay. Some of you, here I'll just split the page and change colors. Some of you will be able to see that you can factor out the 3. Like that. Okay? Without the substitution. And then you could go right from there to there next as a difference of squares. You're able to hold all of those numbers in your head and feel like it's still just a squared minus b squared, a difference of squares. That's perfectly fine as well. Okay? But sometimes when we have so many numbers, it's hard to see the common factor of 3. When I changed it to a and b, that might be easier for your brain to go, oh, I see the common factor of 3 easier now. So you might like that. Okay, questions to circle here. 12, 13, and 14.